Hi, and thanks for joining me for the quads graphing homework tutorial. Um, there was a lot in our lesson today, so I thought I'd make a tutorial for the homework so that you could get another mini lesson. As we noted in our class, the first problem, we already know how to do this from our previous knowledge, and we're going to use our previous knowledge that tells us that if I go ahead and rewrite this real quickly in a way that we're used to seeing, we remembered that this is our left and right transformation, and this is our up and down one. So we're going to use that knowledge to graph here because I believe it's important to use past knowledge to help and transfer in new situations like a new test. So here we go. We know our vertex is not going to be shifted to the left or the right because there's not a number next to x. I put a 0 there so you could see that. But it is shifted up 1. So our vertex, instead of being on the origin, it's shifted up 1. And then to go ahead and graph, we need to remember what the parent function, the graph of the parent function looks like. And when we think about the parent function, y equals x squared, we know that the vertex is on 0, 0, because there's no movement left or right or up and down. And we know that it has a pattern. As we move to the left or to the right 1, we move up 1. As we move to the left or right 2, we move up 4. 1, 2, 3, 4. And we talked about why that is before, so we're not going to repeat. So we remember this pattern, though, for a parent function. When we move to the left or to the right 1, we go up 1. When we move to the left or the right 2, we go up 4. And so we always are comparing that, and we look at this, and we see a negative. That means that each one of our normal patterns is going to be multiplied by a -1. So we're used to, when we move to the right 1, we're used to going up 1. But we're going to multiply that 1 by a negative, or a -1. And instead of going up 1 when we move to the right, we're going to go down 1. So our pattern is being flipped by that negative. Instead of when we move to the right 2, instead of going up 4, we're going to go down 4. 1, 2, 3, 4, because it's being multiplied by the -4. So we're graphing using our knowledge of the patterns of the points that are part of our parent function. And there we go. Our next one is going to take some ingenuity of also transferring the knowledge we gained about factoring. And so when we're looking at this to graph, we're going to find our x-intercepts. We want to know, when is this graph equal to 0? And so we go ahead and set it equal to 0. I know we're used to having our 0 on the right side, but it's okay to have it on the left. And so what we're going to do is we're going to factor. We're going to think of two numbers that multiply to equal -6 and add to equal -1. I'm thinking about 3 and 2, right? Because 3 times 2 is 6. Which one should be positive and which one should be negative? If I make the 3 negative and the 2 positive, that works, right? -3 times 2 is -6. -3 plus 2 is -1. And so the wonderful thing about having something times something equals 0 is that either x minus 3 is equal to 0 or x plus 2 is equal to 0. One of them, at least one of them, has to equal 0. When we solve, we get x equals 3, and we get, and we get x equals -2. So what have we found here? These are the values for x when the graph has no height. When the graph is at 0, and we call these x-intercepts, we also call them roots, we call them zeros. So we're going to graph them. I see a 3 here, and I see a -2 here. So this is great. We already have 2 points for our quadratic, but we need more than 2 points to sketch this quadratic. So we move on and we think, well, if we have the 2 x-intercepts, why don't we go ahead and find the vertex, and then we can sketch our quadratic from there. And that's what we're going to do. So we look at these 2 points that were given, and we know that our line of symmetry is going to fall right between the 2 points. So let's see. We go over 1, 2, 3, 4, 5. What's half of 5? 2.5. So we move from the -2, 1, 2.5, and right here, okay, I'm not aligned totally, so it's looking like it's not a half. I'm going to put this dotted line, and what this dotted line represents is the axis of symmetry. No, you don't need to do this for the test. It just helps us to remember where our vertex lies, because the vertex lies on the axis of symmetry, and then either side of the quadratic is symmetric from there. So how are we going to find out where our vertex lies? Well, the first thing that we did was we found the middle. So we found the middle between -2 and 3. We just found it logically in looking at our graph, and we found that the middle was 1/2, right? So we'll put 1/2, or we might put 0.5 because that might be easier to put into our calculator. So we know that the vertex, the x value, is 0.5, and now we just need to know how high or how low do we go so that we know where to put this point. And so what we're going to do is we're going to take our original formula, y equals x squared minus 1x minus 6, and we're going to plug in a 0.5 when we see x. So we'll plug in a 0.5 here, plug a 0.5 here, and then we're going to put exactly what we have written in our calculator, including the parentheses. That's really important. So right now, I'm putting it in my calculator. And I'm getting -6.25. And it says y equals -6.25. So what this is telling us is that for this quadratic, when x equals 0.5, y equals -6.25. And because this is our vertex, it's very important. So we're going to go to the, we're going to graph it, and our point is 0.5 comma -6.25. We're not going to be exact, especially because I'm not super aligned. But there you go, there's our vertex. And now we're going to go ahead and connect these 3 points, and we've got our quadratic. So just to go over this type of problem again, we look at it, we see that we have a trinomial, and we know that with trinomials we have 2 choices, quadratic formula or factoring. We saw that we could factor to solve, and the reason why we set it equal to 0 is that when we did that, when we made y equals 0, it allowed us to find our x-intercepts. And so we set the trinomial equal to 0, then we factor. We found 2 numbers, -3 and 2. They multiply together to equal -6. They added up to equal -1. Then we used the multiplicative property of 0. We set each one of those equal to 0. We solved, and we found our 2 x-intercepts, one at 3, one at -2. Then we found our halfway point between -2 and 3, and that was located at 1/2. We drew our line of symmetry. You don't have to do that on the test, but it just reminds us where our vertex goes. And then our midpoint, the 0.5, gave me my x value for the vertex, and then I plugged in the 0.5 wherever I saw x, plugged into my calculator. I got -6.25, which is our y value for the vertex, graphed it, connected the 3 dots. Then number 3 says, on problem number 2, so I went and I copied problem number 2 so we don't have to keep switching back and forth. So it says, on problem number 2, identify where the graph will have y values of 6. Write your solution as an ordered pair. Okay, so it's saying, let's make this a little bit bigger. In fact, let's just bring it down here. It's saying, for what values of x will y be equal to 6? Or let's say it another way. If y is 6, what does that mean x has to be equal to? So we're going to find out. We're going to go ahead and plug 6 in for y, and we're going to solve for x. So we're looking at this, and we notice we can't use the square root method because there's both an x squared and an x. So that leaves us either our quadratic formula or factoring. So either one of those, we know that we have to get a 0 on one side. So we're going to go ahead and subtract this 6, so we have a 0. It's okay, we can live with the 0 being on the left side. And we look at it, and we're going to try to factor first. If we can't factor, we will use the quadratic formula. But when I think of 2 numbers that multiply to equal -12 and add to equal -1, I think about -4 and +3. right? Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. That works. And because we have something times something equal to 0, we know that either one of those somethings or both those somethings have to be equal to 0. So we go ahead and solve. We get x equals 4, x equals 3. What do these x's even mean? Well, since we set the equation equal to 6, it means that when y has the value of 6, okay, so let's set them up as points. When the y is equal to 6, there's two possible x's that can give us a y that's equal to 6. Either x is 4 or x is 3. So if you wanted to, we could go back and see if that looks reasonable for the graph that we just drew. Would 4, 6 and 3, 6, I'm sorry, 4, 6, I dropped my negative. That wouldn't make sense probably. Let's get that negative. So would 4, 6 and negative 3, 6 be on our graph? Let's go back and let's look. So 4, 6 would be right about 4, 6. That looks very reasonable. If we continue to bring up the blue line, negative 3, 6, I'm sorry, I should be doing 4, 6, not 4, 7. Okay, 4, 6, and negative 3, 6. Both of those look that they're right on track. So once again, the question asked for what values for x will give us a 6 for our y? And our answer is 4 and negative 3. Okay. So this next one we need to graph. We cannot do the square root method to solve for x. Once again, we're going to be looking for our x-intercept, so we'll set it equal to 0. I'm going to go ahead and set it up in a way that makes sense for me. So negative x squared plus 6x equals 0. I'm looking for my x-intercepts. Once I find them, then I'll find the middle, find my vertex, and go ahead and graph it. So I'm looking at something where I want to solve for x. I want to get something times something equals 0, which means I'm going to need to factor. I'm going to factor out the negative x. Whoops, almost made a mistake. Well, I did make a mistake. I'm correcting it. Does this make sense? If I distributed, and I would multiply negative x times x, I would get back to the negative x squared. Negative x times negative 6, I get back to the 6x. So factoring, once again, is undistributing. And so then I would have something times something equals 0, so I'd set both of them equal to 0. So either x is 0 or x is equal to 6. Those are my two x-intercepts. It was interesting because second block noticed there was a little shortcut. They noticed, because we had practiced a lot of these on the marker boards, and they noticed that they could skip the factoring, and they noticed that 0, when you plug 0 in for x here, in here, that's going to give you a 0. When you plug 6 in for x, it's going to give you a 0. So some of them skip the factoring altogether. If you can think logically like that and skip that step, more power to you. So now what we're going to do is we're going to graph the two x-intercepts. We're going to graph them at 0 and 6. And now we need to find our middle so that we can find our vertex. So let's look at what's in the middle between 0 and 6. Well, halfway is 3. So we're going to go ahead and put our line of symmetry here. Once again, this is just to help me remember that my vertex goes right in the middle. You don't have to do that part if you don't want to. But since I'm doing the vertex, I know right away the first number is found by finding the middle, right? The middle of my two x-intercepts. And the second number is found by plugging in x to solve for y. So my formula is y equals negative x squared, what is it, plus 6x, right? So I'm going to go ahead and plug in 3. Note, I'm going to write my negative. When I plug in my 3, it is just like this, because that negative doesn't have anything to do with my 3. My 3's got to get squared first, then it can be multiplied by that negative. Your calculator knows order of operations, so make sure you put put it in just like that. Otherwise, your calculator will give you the wrong answer. So let's see. I'm going to do this without my calculator. I've got 18 minus 9, which is 9. So that means my vertex is 3, 9. So I'm going to come back over here. The 3, 9. Let me switch back to blue. So there's my vertex. I've got my vertex, my 2x-intercepts, and I am good to go. See how much time we've got left. Okay, not bad. So let's go over that real quickly. We factored to find the 2x-intercepts. Some people saw a shortcut and knew that 0 was always going to be, for this type of problem, an x-intercept, and that this number right here was going to be the other one, where there was a positive 6 or a negative 6. And then we found our middle, and then we plugged our middle into the formula, to the equation, and we solved for y, and that's how we find our vertex. It's the middle, and it's the height is whatever we solve for, the number that we get when we solve for y. Okay, so here, number 5, we're going to use our prior knowledge and apply it in a new situation because it's a different test. And so we're going to remember that our vertex can be found by reminding ourselves that it's the opposite of what's by our x, so it's going to be 2, and it's up 10. So when I graph it, my vertex is going to be over 2, up 10, right there. Okay, so we've got our vertex. Then we have to find our other points. And how I teach this is that I remind my students about the parent function y equals x squared. And I remind them that it has a pattern. Over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. And so if they can remember this pattern, then they can use our new slope. It's not really a slope, it's a quasi-slope, to help us. So my first points are always up 1, but when I have a negative 5, that tells me 1 times negative 5, which gives me a negative 5. So my points, instead of going over 1, up 1, I'm going to go over 1, down 5. Let's see here. And over to the left, down 5. And then same thing, my second point, when I go 2 to the right, I usually go up 4, but no, there's a negative 5 there. So negative 5 times 4 is negative 20, which, okay, I'm going to go over 2 and down, negative 20, and where's that put me at? Negative 10. Same thing, I'm going to go to the left 2. Normally I go up 4, but this time there's a negative 5 there. So 4 times negative 5 gives me my negative 20. So I go down, there we go. It's a nice, crazy quadratic. There we go. So with that one, we're using prior knowledge and our knowledge and understanding of the pattern of our parent function graph. On problem 5, so I got problem 5 on this screen so we could be reminded of it. Identify where the graph will have y values of negative 10 and write them as an ordered pair. Okay, so once again, we're doing the same thing. We're going to plug negative 10 in when we see y, and we're going to solve for x. We wonder, hey, what x's out there, when I plug them into this equation, will give me a y that's equal to negative 10. So I see this part, okay? I see the x minus 2 squared, and I don't see x anywhere else. That tells me I'm going to solve this equation by using the square root method. So I'm going to get rid of everything that's around here. I'm going to get the square root. I'm going to get it by itself. So I have this. Then I'll go ahead and divide both sides by negative 5. Isn't it nice to be able to use stuff that we've learned previously to help us solve current problems? I love that. So we're going to take the square root of both sides, plus or minus. Square root of 4 is 2. If this looks confusing to you, it's because you need to go back and review your square root method. I'm going to switch it up. I'm going to say x minus 2 equals a positive 2. X minus 2 equals a negative 2. I'm going to solve for both. So I have x equals 4. and x equals 0. What do these x's even mean anyways? Oh, that's right. We put negative 10 in for y, and when we did that, we got that x equals 4 and x equals 0, which means that when x is 0, y is 10, right? Is that what we put in there? Nope, negative 10. And when x is 0, I'm sorry, when x is 4, already got that one. When x is 4, y is negative 10. So what we're going to do, that's our answer for this problem, but what we're going to do is we're going to look back at the graph that we just did and see if that makes sense. So let's see, 0. Okay, sorry. I'm losing where we're at. So what were my 2 points? 0, negative 10, and 4, negative 10. Let's see. 0, negative 10. Yeah, you know, it would make sense if I would have graphed it correctly here. When I move, maybe some of you were saying, Miss Overby, no, you went over one too many. Very true, because I should have gone over 2 and then gone down there. So 0, negative 10 is there, and look at that. 4, negative 10 is there. So actually, if we would have been paying attention, Miss Overby, we could have answered number 6 just by looking at our graph. It says when y is equal to negative 10, what values of x is there when y is equal to negative 10? Well, there we have it. X is 0 here, and x is 4 here. If it's like that on the test, be observant, and then you can skip all of that work. All right, it's been fun. See you in class.